In this presentation, we will examine how organizational design, culture, and leadership approaches influence the quality outcomes within Lockheed Martin Space in Huntsville, Alabama. This site plays a critical role in engineering, calibration, and quality assurance functions that support mission readiness and customer reliability. Research consistently shows that organizations with strong structural alignment and cross-functional coordination achieve higher performance outcomes, particularly in high reliability industries like aerospace and defense. Cotter emphasizes the need for alignment and discipline change processes when addressing systemic issues, and Sila highlights the link between culture and consistent quality performance. As we explore the issues facing Huntsville, you will be presented with a comprehensive improvement plan that integrates structural reform, cultural enhancement, and leadership strategies to strengthen both product quality and people performance. The primary issue affecting Huntsville's performance is calibration inconsistency and supplier quality variability. These problems directly affect the fortune metrics of product and service quality and people management. Internal quality data shows that variability in calibration processes and supplier inputs account for a significant percentage of nonconformance reports. This undermines reliability, interrupts workflow, and creates downstream challenges for engineering and production. AS 9100 and NASA mission requirements demand extremely tight tolerances, meaning even small deviations can compromise critical systems. By clearly defining this issue, we established the foundation for examining the organizational structures, cultural gaps, and improvement opportunities that must be addressed to enhance performance. The consequences of inconsistent calibration processes and supplier variation are significant and far-reaching. Increased nonconformance events mean more rework, reinspection, and quality hold points, which all translate into higher labor cost and reduced efficiency. Research by Sila indicates that cultural and process misalignment often lead to these types of failures. Additionally, schedule delays stemming from calibration issues can reduce the organization's overall mission readiness and negatively impact customer trust. Edmondson's work on psychological safety also suggests that hidden or unreported calibration issues pose even greater risks as they may surface during audit cycles or operational use. Ultimately, if these performance gaps are not corrected, the organization risks reduced contract competitiveness and lower award fees, particularly with NASA and the Department of Defense, where reliability is non-negotiable. Lockheed Martin operates with a matrix structure, which means that employees often report to multiple managers across engineering, production, quality, and supply chain. While this design allows expertise to be shared, it also creates dual accountability and sometimes confusion about ownership for quality outcomes. Griffin and colleagues explain that matrix structures often diffuse decision authority and create delays in problem resolution. In Huntsville, this structure contributes to fragmentation and reactive problem solving because information must travel across multiple channels before action occurs. Culturally, the organization excels in compliance and procedure adherence, but it lacks a strong culture of proactive root cause analysis and continuous improvement. Together, the structure and culture make it more difficult to address calibration variability in a sustainable way. Improving these factors is essential for enhancing mission assurance. Internal and external forces significantly shape Huntsville's performance environment. Internally, the aging workforce is a major factor. As senior technicians retire, much of the historical knowledge tied to calibration methodology risks being lost unless captured systematically. Knowledge silos also prevent efficient information sharing. Externally, Huntsville must meet the demands of NASA and DoD audits, which apply strict requirements for calibration, accuracy, traceability, and documented competence. Standards such as AS 9100 and ISO 17025 mandate verification methods, documented uncertainties, and consistent calibration intervals. Supplier variability introduces another external constraint because inconsistency in purchased parts directly impacts calibration results. Understanding these forces helps us design a change plan that responds to real organizational pressures rather than simply addressing symptoms. Conscious capitalism emphasizes purpose, stakeholder integration, conscious leadership, and a culture of trust. Lockheed Martin, at a high level, embraces many of these principles through its mission driven culture and focus on ethical conduct. However, at the operational level within Huntsville's calibration and quality ecosystem, there is a critical gap. Technicians often feel limited in their ability to report issues upward. Edmondson's research on psychological safety demonstrates that when employees do not feel safe voicing concerns, quality issues become hidden and problems persist. To strengthen the organization's conscious culture, leaders must encourage transparent communication, remove fear of blame, and empower technicians to identify and escalate calibration inconsistencies early. This cultural shift is essential for reducing system risk and improving performance outcomes. Applying Cotter's first four steps establishes the foundation for successful change. First, to create urgency, leadership must present clear data showing how calibration problems affect NCR rates, delivery schedules, and award fee scoring. This builds shared recognition of the need for change. Second, we must establish a guiding coalition composed of stakeholders from engineering, metrology, supply chain, and production, along with respected frontline technicians who provide credibility. Third, the team should develop a strategic vision, such as achieving a 40% reduction in calibration related NCRs within a year. This vision must be simple and actionable. Finally, communication is key. Leaders must share the vision regularly through dashboards, team meetings, and visual performance boards. Clear and repeated communication fosters alignment and commitment throughout the organization. Cotter's next four steps operationalize the change. Step 5 involves removing barriers such as outdated calibration workflows, lack of real time data visibility, and fear based reporting culture. Implementing a digital calibration dashboard and standardizing procedures will greatly reduce these barriers. Step 6 focuses on generating short term wins by targeting high impact suppliers and celebrating reductions in NCRs. These wins build momentum and show employees that improvement is possible. Step 7 requires sustaining acceleration by expanding corrective action efforts, reviewing metrics regularly, and maintaining leadership involvement. Finally, anchoring change into the culture means embedding quality expectations into onboarding, technical training, and performance evaluation processes. When the systems reinforce the vision, change becomes the new norm. Managing change requires anticipating resistance and aligning the organization's subsystems. Common challenges include employee hesitation to adopt new tools, fear of repercussions when reporting issues, and suppliers who may resist transparency. Leaders can address these challenges by creating blame free reporting channels, offering hands on training, and maintaining consistent communication with suppliers. Nadler and Tushman's congruence model emphasizes aligning structure, people, information, and rewards. Structurally, Huntsville should establish cross functional quality councils that review calibration data regularly. For people systems, offering certification pathways and mentorship programs helps retain critical expertise. Information systems must provide real time calibration traceability. Finally, rewards should reinforce desired behaviors, such as celebrating defect prevention rather than only production throughput. When all subsystems align, change becomes more sustainable. Effective leadership plays a central role in executing change. Cotter underscores the importance of clear and consistent communication, and Edmondson highlights the need for psychological safety within teams. Creating an environment where technicians feel safe reporting issues is essential for improving calibration consistency. Leaders should model transparency, humility, and curiosity, which supports a culture of trust and continuous learning. Servant leadership principles such as empowering employees, removing obstacles, and prioritizing the needs of frontline workers strengthen collaboration and engagement. Leaders must also avoid strategies that undermine trust, such as punitive reactions to mistakes or implementing top down changes without frontline involvement. By focusing on empowerment and collaboration, leaders help build a resilient, high performing team culture. If the recommended changes are implemented effectively, Huntsville should expect significant improvements in quality and operational performance. NCR rates related to calibration and supplier variation may decrease by 30 to 40%, which aligns with research on quality culture improvements. Supplier quality scores will also improve as visibility increases and corrective actions become more consistent. Reduced NCRs and fewer calibration delays will help stabilize production schedules and strengthen the site's competitiveness for future contracts. These improvements not only support immediate operational goals, but also build long term organizational capability and employee engagement. Ultimately, these outcomes enhance mission assurance and strengthen Lockheed Martin's reputation for reliability and excellence. In conclusion, calibration variability and supplier inconsistency present meaningful challenges to Huntsville's performance, but they can be addressed through an integrated, structured approach. By analyzing the organization through structure, culture, and external forces, we have identified areas requiring intentional change. Cotter's model provides a proven roadmap for implementing that change in a way that fosters buy-in and long-term sustainability. Conscious culture principles and servant leadership further reinforce trust, transparency, and team empowerment. When the organization aligns its structures, people, information systems, and reward processes, it creates the foundation for a high reliability environment. This alignment will not only enhance quality outcomes, but also strengthen Huntsville's role in delivering mission critical capabilities for national and space defense. Thank you. This concludes the presentation.